System terminal initialized. Welcome to this explainer masterclass. Today, we're doing something completely different. We are running a full-on Silicon Valley-style Cambridge exam hackathon. I'm your lead dev, and we are targeting a very specific, highly secure mainframe today. Cambridge AS and A-level mathematics, specifically syllabus 9709. We are going to reveal exactly what Cambridge examiners, our root administrators, are looking for when they assess trigonometric identities. We're going to treat a complex, multi-part math problem exactly like an algorithm, one that can be solved with clean, precise, code-like syntax. To help us out, I want to introduce you to two junior developers on our team who are going to be taking this journey with us, Dev Alex and Dev Sam. Now, Dev Alex, he's excellent at raw data inputs. He can memorize formulas all day long, but he constantly causes massive memory leaks in his exams because his analysis is just really poor. Then we have Dev Sam. Sam is absolutely incredible at building logical loops, but she fails the syntax precision rules almost every single time and loses all her marks. Throughout this hackathon, we're going to use their code to figure out exactly how to optimize your exam strategy. Let's boot this up.
Let's kick things off with a direct quote from a senior examiner. This perfectly sets the high stakes of mastering this specific syllabus area. They state quite plainly that the difference between a B and an A star in mathematics often comes down to how well you understand trigonometry. Specifically, identities like sec2theta is identical to 1 plus tan squared theta, and cosec2theta is identical to 1 plus cot squared theta. This is absolutely crucial. It's not just about rote memorizing a string of characters, it's about deeply understanding the underlying architecture of the math. If your foundation here is buggy, the whole program crashes.
Here is our command matrix for today's session. 1. Core principles. 2. Technical methodology. 3. Critical analysis. And 4. Examiner alerts. Let's get right into it.
Section 1. Core principles. Let's look at the theoretical foundations.
Okay, these two star identities are the absolute building blocks of this entire topic. Their theoretical architecture rests entirely on precise definitions and causal relationships. Remember Dev Alex? This is exactly where he runs into trouble. He tries to brute force his way through the exam by just inputting the raw data. He knows the formulas, sure, but he doesn't actually understand the logical, structured reasoning behind why sec2theta is identical to 1 plus tan squared theta. When an examiner throws a curveball, a slightly altered parameter, Alex's code completely breaks. You simply cannot just input raw data at this level. You need to understand the logic running in the background.
And this brings us to a major system requirement. Cambridge's assessment framework demands logical reasoning. They are heavily prioritizing analytical depth over just having a superficial breadth of knowledge. Think of it like a firewall. If you just casually sprinkle these trigonometric identities across your exam paper, hoping one of them sticks without showing any real analytical depth, the examiner's firewall is going to reject your code immediately. They want to see that you can dive deep into a single complex problem, not just skim the surface of 10 easy ones.
To clear that firewall, you need to hit 3 distinct cognitive domains, which are the core assessment objectives for these identities. First, there's knowledge and understanding. That's your baseline, your standard library. Next is application. This is where Dev Sam usually excels. She can take a formula and apply it to a basic loop perfectly. But it's that final tier, analysis, where both of our coders often hit fatal syntax errors. You have to be able to tear a problem apart, analyze its components, and rebuild it. You must successfully compile all 3 of these domains to secure top marks.
And here's a massive cheat code directly from the principal examiner reports. They explicitly highlight that candidates who successfully integrate these identities with other syllabus areas are the ones who consistently achieve the A stars. We're talking about linking trig identities with calculus or blending them into quadratics. Your code cannot run in isolation. It needs to integrate seamlessly with the rest of the mathematical system. When you make those cross-topic connections, you are signaling to the examiner that you are a master programmer of this subject.
Moving on to Section 2, Technical Methodology. Let's map out your procedural framework.
Whenever you are tackling these high-tariff past paper questions, you must follow this standardized 5-step sequence. Consider this your official command matrix for debugging any problem. Step 1. Deconstruct the prompt. Read it like you're parsing a brand new codebase. Step 2. Extract the relevant data and variables. Step 3. Select your analytical framework. Ask yourself, which identity are we actually deploying here? Step 4. Execute with incredibly clear notation. And finally, Step 5. Present your final output using the correct terminology. If you skip any of these lines of code, your script will fail.
Let's look at this another way. It's a continuous problem-solving loop. Identify, apply, execute, verify, and present. This is where DevSam completely drops the ball. She'll run a brilliant logical loop through the identify, apply, and execute phases. But then she skips verify and present. She doesn't check her output, and her final formatting is a mess. Because of that, she fails the examiner's syntax precision rules and loses massive method marks. You have to close the loop every single time.
Your presentation actually matters just as much as your math. You must follow strict conventions, proper headings, correct terminology, appropriate formats, and clear annotation, because examiners award process marks based on your ability to clearly show you're working. Now, before we push this final patch to secure maximum marks and fix DevSam's syntax errors, optimize your system feed. Subscribe to Ace the Exams at the handle @AceTheExams right now and turn on all notifications for weekly system updates. Okay, resuming the compliant. Listen, if you ever encounter a logic error mid-argument, you need an instant debugging tool. Deploy a structured syntax like PEEL. That's point, evidence, explanation, link. It instantly upgrades your mathematical argument. Remember, clear annotation is quite literally your best debugging tool.
Section 3. Critical Analysis. Welcome to the interactive beta testing arena.
Problem-solving at an elite level requires a strict deconstruct, solve, evaluate framework. You have to constantly check your own work for reasonableness. Okay? Test 1 initialized. Imagine a complex, multi-part trigonometry equation flashing onto your screen right now. You have a 60-second visual countdown clock running in your head. What do? Your job isn't to panic. Your job is to run a trend extraction. Break that complex text string down into logical bite-sized steps. Scan the code, look for the sec2theta or the cosec2theta, isolate that variable, and systematically execute your substitution. It is just logic.
And here is test 2 of our beta arena, the code review. To prove the quality of your evidence, you absolutely must evaluate how any assumptions you make affect your final mathematical conclusions. Look at your own written text block like a senior developer reviewing a junior's code. Are you assuming an angle is acute when the parameters state it might be obtuse? Are you casually dividing by a trigonometric function without stating the explicit limitation that it cannot equal 0? Finding and addressing these alternate interpretations is the secret patch that elevates your answers straight into A-star territory.
Finally, Section 4. Examiner Alerts. Let's look at the top system crashes. Straight from the logs, here are the top 3 fatal errors candidates make, which literally mean the difference between an A-star and a B. Error number 1, forgetting proper format, which causes you to leak easy method marks. Error number 2, forgetting to run a final compile check on your presentation. And error number 3, deploying an answer that isn't specific to the context or domain given in the prompt. This is a classic Dev Alex move, right? He gets the raw data exactly right, but applies it in a completely wrong context. The system will reject it every time.
Let me issue a critical warning directly from the source code. Never, ever assume the examiner knows what you mean. The reports show that candidates consistently confuse key terminology between sec, cosec, tan, and cot. Do not do this. Always define your terms and write out your identities clearly before executing them in extended answers. Don't hide your background processes. Make your code open source for the examiner so they can award you every single method mark available.
To make sure these identities actually stick, and to prevent any memory leaks during the exam, I want you to try this memory hack right now. Create a personal mnemonic to lock in the terminology forever. Think of something like, secretly, 110 is second to none, or costar is 1 and cot make cosec. Honestly, whatever weird, quirky algorithm works for your brain, write it down right now and compile it permanently into your long-term memory.
All right, let's initiate the final code deployment. Our cheat sheet architecture boils down to 3 core commands that you need to take away today. 1. Master the precise definitions of your underlying identities. No superficial knowledge allowed. 2. Execute the standardized 5-step framework to strictly secure your method marks. And 3. Constantly audit your own work to avoid those formatting and context traps. If you take away these 3 crucial points, you will transform these complex identities into an incredibly easy, reliable source of method marks.
Remember, this code only runs smoothly on exam day if you actually practice compiling it yourself. You need to take this methodology and apply it to real past paper questions. Thank you for joining this Silicon Valley Cambridge Exam Hackathon. To secure maximum marks and ensure your system is fully updated, I need you to subscribe to AC Exams at the handle @ACExams, click the notification bell, and leave a comment below with your specific subject and level so we can build the exact next update you need. I'll see you in the next masterclass, but until then, I want you to ask yourself, are you just blindly inputting raw data into your exam paper, or are you actually writing the code for an A star?